A probabilistic machine learning approach to online recruitment system. Dissertation proposal Mahdi Muqaddasi.
So what is e-recruitment? Online recruitment system or e-recruitment basically is a service that automates a process of the company's recruitment. It works by getting a volume of the employment information over a source like the internet and then processing this data to finding a possible job matches for the candidate. So it makes the process of the finding a job for an applicant or finding a candidate for an employee much easier than the traditional methods that applicants uh, perhaps contact tens, if not hundreds, companies to finding a great match. With the nowadays technology, this process can be through a portal, web portal, or even with the mobile app that the user can search for the potential matches. The evolution of the initial um, pioneer in this area, perhaps back to 1994, when the Monster.com was among the first company that emerged as an online tool for organization to contacting the potential candidate. There are about maybe hundreds of these type of the companies that are providing such services. For example, LinkedIn, Dice, or Indeed are among the top pioneer in this area. We will discussing about the common features that are across of these web portals or the companies that providing services for the users to finding a job, and then later on we will discuss what will be the alternative innovation that we discuss in the proposal that will not have the limit that the current services has. By looking at some of the famous job search websites like the LinkedIn, we observe that almost the search process for the users is common across all of these websites. Basically, these are portals that search thousands of index job application from their database and retrieve jobs based on the query that the user is specified. In this process, an applicant needs to enter one or few keywords to specify what he is looking for, such as a job title or a company name, and then narrow down his search into geographic location for the search query. We will go through an example in the following slide. In this example, I choose LinkedIn as a website that I'm using if not daily, but quite often for job searching routine. As I said in the previous slide, the common approach is divided into two steps. Step 1, enter what to look for. Say I'm interested in the data science position, so I enter the keyword data scientist in the what text box. In the next step, I enter the place where I would like to finding the data scientist position. In this case, that will be Plano, Texas, where I live. And then finally, after I click on the search button, I see the result of my query, which will be including job description, company name, and the place on the website. There is also option to save the query so I can receive daily or weekly emails for the search or add a more filter to the search so it makes it exactly as the query that I enter. Although the search process is very common along the major research portals, but in my view, it has some limitation. Firstly, the user needs to have the pre-knowledge on what he is looking for before using these websites. For example, a recent university graduate or someone who has a less industrial experience, this may not be a good fit if he's not very familiar on what needs to be looked for in order to finding a best match. An applicant may enter the term data scientist as a keyword without considering that if he was using NLP specialist engineer as a text in his search, he could then finding more correlated term that may lead to even more related jobs. So there are two concepts of the recall and precision here that we're just discussing about the recall concept. So there are jobs outside that may not be retrieved for that particular user simply because he didn't know how to use that particular term in order to finding those jobs. The second problem or the second subject is how to know if the job is a potential match for an applicant based on his previous past experience and his skill sets. Give an example in this area would be consider a data scientist job description A that requires experiences in tools such as Microsoft Excel, and this doesn't basically include any cutting-edge technologies or anything special. And then we have a data scientist job description B that is more complicated in the sense that it comes with several bullet points requirement like at years of experience in programming languages as well as the knowledge of the machine learning algorithms. Now the question would be, how do you differentiate between these two job descriptions without knowing the previous experience? This is the concept of the precision. If we don't consider years of the experience of someone who just looking for a job, we may providing both two jobs as basically a list of retrieve query output. So job search is more a classification problem in order to finding the best job we can consider as applicant to be classified for a specific job. So far we have discussing about the two problems of the recall and the precisions, and in these presentations we are discussing about how to address it. So in order to users to using the retrieving all the available jobs that is more correlated to his backgrounds, we are planning to using his previous experience that usually will be indicated in his resume, and with that information finding the jobs that is more correlated to his previous experience. We will discuss about the org architectures in the following slide. As is showing in this website, the process is started by a user uploading his resume. This will be done in the upload the resume module. The format of our system for now is a PDF format, but it can easily modify to the other popular format like a doc and text file as well. So once we get the resume in the PDF format, we will convert it to the TXT, and then we will start to parsing a line by line of the resume, looking for the specific pattern, which is showing here in the module resume parser. The idea behind that is using resume parser and the other module, which is a skill set dictionary. We want to find it out that for particular applicants, how many years of the experience he has for particular technologies, which couple of them as an example is showing here. So the output of these two modules together will be a vector, which we call it as a skill set vector, which has the term of the technology, for instance, Java, C++, or the Pythons, and the years of the experience that is associated with that. This skill set vector plays a key role in our system because this is the way that we can compare a particular job with the resume of the applicant. So we know that based on the database that we have, what will be the job that if we are comparing to a skill set vector of the job and the applicants, the years of the experience that the user has is at least higher than the one that is showing in the job list. And then we will retrieving those and we'll show the output in the list of jobs, which is module number 4. This is the online system that will be interacting to the users. But in order to feed our database with the available jobs, we have another module which is highlighted here and is responsible to crawling the internet, finding pages that listed for a job, and then basically creating a skill set vector out of the job and store it into the database. As of now, we are looking for site indeed.com in order to finding a list of the jobs and updating our database. So in order to compare the similarity between a resume and the job, in this project we are using a skill set vector. So a skill set vector is a metric to summarize a resume as well as the job requirement from a job post. And each time a user uploads his resume, this vector is creating for that particular applicant. And each time that the web scraping application finding a job post, the same process will be finished in order to summarize that job post and store the information of the requirement of the job in our database. So when we are basically searching in our database, we are comparing the skill set vector of the resume against what we already store in our database regarding to the set of jobs. As an example is consider an applicant Joey who has 2 years experience in C++, 5 years in Python, and other basically years of the experience in the different technologies, and that has been extracted from his resume. And then we have a list of job A and job B that has a requirement of knowing C++, for instance, 5 years in job A, and Java 10 years, 2 years of a skill server, and so on. And then in job B, the minimum requirement is 1 year in Python, 2 years in R, 5 years in Java, and 3 years in Cassandra. So now that we have summarized those informations in the skill set vector, we can look at each skill as a one dimensions, and the years will be basically the scale of that dimension. And we can use a cosine similarity in order to know that what will be the closest job for that particular applicant. And based on that, we can sort a result and providing the result in the output. In this next slide, we are planning to show a demo of how our system working based on a resume that is uploaded and how the basically search will be shown in the portal. At this part of my proposal presentation, I would like to follow up with a demo on how the job web portal works. This is the current prototype, which doesn't have the machine learning engine attached to it. And the goal was more providing a look and feel of the UI and basically how the UI works. And then the next phase, machine learning engine, which included several classification algorithms, will be attached in order to calculate the similarity between the resume and the job. So let's go ahead and start it by choosing a file, which in this case I will pick my resume from my local laptop. And then after clicking on the upload, what's internally happen is the resume will be parsed
against, and then the skill set vector will be compared with the database of the job list that we have. So the result that is showing here, and this value of the basically percentage, is the output of the cosine similarity between the skill sets of my resume against the basically the job listed skill set that has been extracted, and then the cosine similarity of those two vectors has been calculated, converted to the percentage, and then shows in the output. And this value has been sorted. So the top one is 30. So what 33% means? It means that my resume will be 33% match to this particular positions that is from the staple in these locations, Santa Clara, California. And then there are also necessary skills for this job that has been extracted from the job post, and it will show that what are those necessary skills. Like I said, that this similarity is based on the cosine, but in the next phase of my the dissertation, my plan is to calculating different way to finding similarity between the vectors, as well as working on the skill set vectors when I'm parsing a resume to making sure that the data, that the way that it's been established is accurate enough. So in the bottom of the page, there is a way that to go into the different basically different pages which showing the other list, and as you may notice, there is a 1 to 10 pages which are included all the set of jobs that has been available across the database, and the job vectors has been compared with. So this is the way that it works. Back into the first homepage of the applications. The application as of now will accept only the resume in the PDF, but modifying in such a way that will accept it from the different format will not impact it on the accuracy or the performance of the model. So that was a brief on the job portal website.
So far what has been done was using a cosine similarity as a metric to show the similarity between an object to be classified. The next approach is to using the machine learning classification algorithms in order to know, for instance, if a particular vector, skill set vector is close to the other set of the skill set vector that we have. Some of the algorithms in this area that can be used as a classification can be KNN, supervector machine, and decision tree. And we are planning to using, if not all of them, but majority of the most popular classification algorithms in machine learnings, and compare the pros and then disadvantage of any of those based on the performance that we observe in this research. As a part of the analysis of the performance of the different classifications, there are several metrics that will be measured. For example, recall, precision, ROC curve, and F measure. These are the metrics that will be considered as a performance metrics in order to comparing each model and knowing that which one is basically doing better than the other remaining one. and then the result we will discuss in the dissertation as well. And that was my proposal. Thank you very much.